Hello and welcome to another fun-filled adventure in math with Mr. Sims. Today I will be doing your test incentive video for cycle 20. So once again, you do have a test. I know you're thinking, man, we got tests still? Yeah, we still have tests. And the good news is I'm still here for you to help you get those 10 free bonus points and really just to help you, basically just go through all the stuff we've been doing. Now, if you haven't already looked at Mrs. Westall's wonderful completed examples for review day 119. If you haven't looked at those, she basically does half the study sheet for you, and I'm making sure that I do not do the same problems that she did. So basically, you're getting twice the number of problems ready for the test if you look at hers and you look at this one together. I do highly suggest you do that because since you haven't been sitting in class, you're not seeing all the examples. We're not doing the examples together as much. So any help that you can get, remember, if you're not actually actively doing it, you're not learning. So make sure you grab a pencil, make sure you're working through all these things together, and if you're doing that with us, you should actually be pretty good. Anyway, we wish you the very best. Good luck. Grab a piece of paper and pencil now, and let's get started. Once again, in the upper right hand corner, you should write your teacher's name, your period number, and your name. Let's see, and the date. Go ahead and write the date you did it as well. All right. Okay, without further ado, in the bottom right hand corner, why don't you draw a picture of the coronavirus? Yes, all right. And then you can draw yourself kicking its butt. All right, so I don't know how you want to interpret that, but go ahead. Once again, obviously we're not trying to physically fight the coronavirus because first of all, it's very small because it's a virus, and second of all, basically that would be a bad idea because you'd be exposing yourself to it. So the whole idea is don't expose yourself to it, but go ahead and draw that just for fun. All right, moving on. Here we go. Which relationship can best be described as causal? This word is causal. So which relationship can best be described as causal? What we mean by that is that one literally causes the other. All right, if it's a causal relationship, then what's happening is one must lead to the other. Okay, so I'm just going to go ahead and write must lead. It has to lead to the other one. If it doesn't have to lead to the other one, then it's not a causal relationship. So let's look at height and gender. Height and gender, although males do tend to be taller in general than females, that does not necessarily mean that if you are a male, you will definitely be taller. That is not necessarily the case. So unfortunately, that is out. Unfortunately for Mr. Sims, that is way out. Number of pets and type of pets. So number of pets and type of pets. If you have a certain type of pets, like let's say cats, yes, you do tend to have more cats than you would if you had like dogs per se. But does it must lead to that? If you have cats, will you suddenly decide to have a bazillion of them? No, the answer is no. So that it doesn't definitely lead to that. How about age and running speed? As you get older, does your running speed tend to increase? And what we do notice is yes, there is a positive correlation. However, is it necessarily the case? No, as you get older, you can get a bum knee or something like that, all of a sudden your running speed drastically decreases on you, right? So if that's the case, that is also not a causal relationship. How about this? Miles driven and the gas used. So if you're in a car and you're driving, well, of course, if the car is, assuming we're talking about a gas car, right? Of course, as you drive, you use the gas in your tank to propel yourself forward, right? Well, that's not exactly how it works, but anyway, the internal combustion engine and all that. But you get the idea. Basically, the miles driven as you drive, it must follow that the gas must be used in order to make the car go forward. So therefore, that is the causal relationship. Ta-da! All right, without further ado, let's continue. Victory will be mine. All right. There is a negative correlation between the number of hours a student plays video games and his or her math test scores. Oh, Yeah, that's probably true. All right, so here we go. And I love video games. So, hey, there is a negative correlation between the two. Well, let's see. All right, so if we're talking about it's telling us that there's a negative correlation, right? So it's telling us there's a negative correlation between the number of hours the student plays video games and his test score. So in other words, as the number of hours he plays video games increases, we should see a decline in the test scores, right? So let's look at the first one here. They increase by the number of hours, and the test scores stay relatively the same. Well, that is not correct. We are looking for a negative correlation. That negative correlation tells me it's going to have a negative slope. And remember, that's a negative slope. That'd be a negative rise over run. So this one here, you can see it has more of a positive slope. As he plays more video games, his test scores actually increase. Although we would all like for this to be true, that is in fact incorrect. How about this one? Oh, I forgot to set the timer. Alexa, set a timer for 30 minutes. All right, I got one free question in there. Okay, here we go. So number of hours and test scores. This one here looks like statistically no correlation. It looks like basically like stars in the sky, right? We're not talking the Milky Way stars in the sky either. We're just talking random spattering of stars in the sky. If it looks like that, that's an example of what we would call no correlation, okay? No correlation. So because that is no correlation, that is not the one. We're looking for a negative correlation. And here, finally, as you can see, there's a general negative slope there, right, happening. So because of that general negative slope happening, as the number of hours increase, his test scores go down. This is correct. His or her test scores go down. I met some girl gamers too. So here we go. Which situation describes a correlation? That is not a causal relationship. People are wearing pink. It is Wednesday. What the? Okay, that's not a causal relationship. So not causal basically means one does not lead to the other, right? Because if it was causal, one would have to lead to the other. This is not causal. It doesn't necessarily lead to the other. So people are wearing pink. It is Wednesday. Does it being Wednesday lead to wearing pink? The answer, I believe, is that this is the answer because it's not the causal relationship. But I always like to check all my answers, okay? So the more miles driven, the more gasoline is needed. Well, that one is definitely a causal relationship. You will use more gas as you drive more miles. So that one is a causal relationship, but we want the one that's not a causal relationship. So we want the one that's something else. Okay, it's the more powerful the microwave, the faster the food cooks. That is, in fact, a causal relationship as well. You have more microwaves irradiating your food, making those H2O molecules spin like tops and rub in friction. And so, yes, it will cook faster. The faster the pace of a runner, the quicker the runner finishes. Ha ha! That's true. If the runner is running at a faster pace, we're not saying he's a faster runner. We're saying he's running at a faster pace. Ergo, he will finish the race faster. So that is a causal relationship as well. So all three of these were causal. This one here is not causal. There is no reason that it being Wednesday would affect the what's it called? You know what I'm talking about. All right, here we go. Ooh, that was fun. I like that. Let's do that again. That was fun. All right. So the typing the scatter plot shows the average words per. I think this should be per minute. A person types based on the number of weeks of practice. Pardon me. Excuse me one sec. All right, so typing the scatter plot shows the average words per minute that a person types based on the number of weeks of practice. Use the points 124 and 880 to write the slope-intercept form of an equation for the line of best fit shown. So basically, they give us 2 points. This is going to be my x1. This is going to be my y1. This is going to be my x2, and this is going to be my y2. So now that I have that, if I want to write slope-intercept form, there's 2 pieces of information that I need. One piece of information that I need is... Let me see here. So one piece of information that I need is the slope. So let's go ahead and start by finding the slope here. So m is equal to y2, remember, minus y1 over x2 minus x1. And this really should be one that you've committed to memory by now at this point in the year, all right? So let's go ahead and keep working with it. We have 80 minus 24 over 8 minus 1, which is equal to, what's 80 minus 24? That's going to be 56, right? Did I do that right? Divided by 7. I did that right? 80 minus 24. Yeah, I did 56. 56 divided by 7 is equal to 8. Cool. So this is my slopey, my slope. So my m, right? Your m is equal to 8. My slope is equal to 8. So remember, I want to put it in the form y is equal to mx plus b. All right, so in this case here, I have 8 here, right? Now here's the problem that we have. Normally we would find the y-intercept from there, but I can't actually tell exactly what that y-intercept is. And that bothers me. So I'm going to show you another way that you can get this b value here. I could plug in one of these. Never mind. I don't have to do it that way. Let's do it like this. So I want to get it to y is equal to mx plus b, right? But I'm actually going to do, I have now a slope and I have a point, so I can use point slope form, right? Point slope form, remember, is y minus y1 is equal to m times x minus x1, right? And that's equal to 8 times x minus my x1, which is 1, right? And is equal to y minus my y1, which is 24. All fun and games. So now that I have that, I have an equation of a line, but it's not in slope-intercept form. This form here is called point slope form. It's labeled as such because it has two key pieces of information. It has a point and it has a slope. So remember, my point I would get from these and my slope I would get from there, right? So point slope. So I need to now convert it to y is equal to mx plus b, and I do that by solving for y. So first step I'm going to do is distribute in my 8. I get 8x minus 8 is equal to y minus 24, right? I'm going to add 24 to both sides. And in so doing, I'm going to go ahead and do that over here. I get y is equal to 8x. Negative 8 plus 24 is going to be, my brain just stopped, 16. Positive 16. So y is equal to 8x plus 16. So I'm going to go ahead and put that there. 8x plus 16. mx plus b. All right, perfect. All right, well, hopefully this has been enlightening for you. Let's go ahead and continue on. So we got this one here. That was fun. Let me do that again. Well, that did not work as well as I hoped. Moving on. So Beverly did a study this past spring using data she collected from a survey. Let me just erase some things because these are really bothering me. Did I not change my vector layer? I didn't. Haha, new vector layer. Hold on one sec. So this is going to be writing. Okay. So there we go. So I can erase right with it. Okay. So let me go ahead and just erase this while I'm at it. Oh, man. I've just messed it up good now. Hold on. And this. I just can't stand those. All right, here we go. So Beverly did a study this past spring using data she collected from a survey. She recorded responses for people aged 10 to 72 for a number of emails they send per day. The results are shown to the right. So we see as the age increased, the number of emails decreased per day. Given this information, which statement can correctly be concluded? So, getting older causes you to send less emails. Is that true? Can you conclude that from the data that getting older causes you to send less emails? Well, as you can see, people who are older send less emails according to our data. But did it cause it? Did growing old suddenly make you send less emails? And I do not think that that is the correct answer from the data. Although the data does show, yes, that people do do send less emails as they get older. It's not the cause of it. So older causes, this causes makes it incorrect. Getting older causes you to stop using email. Well, if getting older caused you to stop using email, we would actually see it just completely disappear or go down to zero average emails per day. So that is also not supported by the data. There is a strong correlation between age and email usage. Now that we can definitely say is true. So 3 is definitely going to be true. So when I'm looking at my answer choices here, I definitely need a 3. And it looks like this one's the correct one. All right. So B is correct. All right. Here we go. All right. Let's zoom out and let's zoom in. Okay. Here we go. So that didn't work. Let me try again. Oh. There we go. The scatter plot below represents the relationship between the size of your TV and the number of hours you watch it. Huh. I would have seen maybe something go up with that. But anyway, which conclusion about the scatter plot is valid? Well, if you're looking at this just based on this scatter plot, I don't really see any relationship between the two. Like I said, this looks like the stars in the sky, right? And if it looks like just this a smattering of stars in the sky, I'm not talking about like a, looking at a Milky Way where you see like a trend, right? But I'm just saying if it looks like this, where it's just like you just looks like you're looking at random stars in the sky, then that's what we call an example of no correlation. So average time spent watching TV in a week, studies television. There's almost no relationship between number of pets and age. Okay, I think that this graph is not the right graph for this, right? But this would be the one if it was talking about TVs. There's no relationships, okay, between the TV and the size of the television, okay? Obviously, there used to be a different graph here. The older you get, the more pets you have. That is not what we're seeing in the data. The older you get, the less pets you have. No, and 13 years old, you can't have more than now. So the one that would match this data here is what we're looking for is something that states essentially that there's no correlation or that you can't see any relationship between the two, okay? So no correlation. Sorry about that. That was kind of strange and weird, but let's go ahead and go through. Zoom. I'm getting done with these a little bit faster. We might actually get done with this much faster than I anticipated. All right, describe the type of correlation pictured in the scatter plot below. Okay, so this type of correlation pictured. So let's look at a couple things here. First of all, there's two types of when we talk about correlations, there's two types of scriptures that we use. We use one to talk about their relationship to one another, and there's going to be a continuum that's either weak or strong. Okay, so if they're tightly grouped in like a linear format, then that would be what we consider a strong correlation, right? Not necessarily tightly grouped, but if they follow a strong linear pathing, right? Weak would be if you just don't see them following kind of a straight line, right? So weak, strong, and then if you look at there's another one. It's either going to be a positive slope essentially, right, which would be a positive correlation, or it's going to be a negative one, all right? So in this case here, if I'm looking at this, I can see that there is a strong correlation. Like if I just draw my line of best fit, it's going to look something like that. As you can see, that's a pretty strong correlation. They almost lie all on that line, except for this. This is what we call an outlier, right, or an anomaly. So it's kind of a little bit out there, but basically what we have here is a very strong correlation. It's labeled that because it follows that linear pathing, right? Very close to a line, straight line, and it's a positive slope. It's a positive slope. So because it's a positive slope, we would say that this is a strong positive, well, sorry about that, positive correlation. A strong positive, okay? Let's go ahead and zoom out now. All right. So which situation does not describe a causal relationship? Okay. So uh, basically there's going to be a whole bunch that are causal, but we want the one that's not a causal relationship. Remember, causal basically means that it must follow. It must follow from it, okay? So, pardon me one sec. So, okay, so the causal relationship, so there's going to be a whole bunch that must follow, and there's going to be one that does not follow. So the higher the volume on a radio, the louder the sound will be. Well, if you turn up the volume on the radio, will it definitely become louder? Yes. So this example here is an example of a causal relationship. I'm going to put a C here, okay? So that's a causal relationship. But we want the one that's not a causal relationship. So we don't want to circle that puppy dog. In fact, that one's the wrong one. The faster a student types a research paper, the more pages the paper will have. Wow. Hmm. Let's go on to the next one because that one's kind of tricky. The shorter the distance driven, the less gasoline that will be used. Well, yeah, if you're driving less miles, then yes, you're going to use less gas. So that one must follow. There you go. That is a causal relationship. The slower the pace of a runner, the longer it will take the runner to finish the race. Well, yeah, if he's running slower, it's going to take him longer to finish the race. So once again, that is causal. So there's one that's not a causal relationship, but that's this one here. The faster a student types a research paper, the more pages the paper will have. And the reason why that's not necessarily true is it's assuming that it's assuming that if you were typing infinitely, right? If you were typing just infinitely and your research paper had infinite number of pages, you could have as many as you want. Then yes, it would have more pages by you typing faster, right? But the thing is, the research paper might get done at 2 pages, and then at that point, it doesn't mean it's going to have more pages. You just got done with the paper faster, right? So you got done writing the paper faster, but it's not going to have more pages, right? Like if your teacher just tells you that it's a 2,000 word essay, right? Well, congratulations, you typed faster. You just get done with the 2,000 words faster. It didn't mean that you suddenly had more pages, right? So it did not follow. That was not a causal relationship. Ergo, this one is the one that we're looking for. This is not causal. It's actually correlation. Actually, that doesn't help us making it C, because C could be correlation or causation. So anyway, but yeah, this one was maybe a correlation. Maybe I'm not even sure that's a strong correlation, to be quite honest. I'm not even sure that's a correlation at all. Anyway, we'll see. Here we go. Moving on. Maybe a little bit of one. I have to research that. Okay, here we go. Pew! I don't know why I make sound effects. It just feels right. All right. Whoops. J. J. I have no idea how to pronounce the name. Jaana? Jaana? I'm going to go with Jaana. Jaana? It's probably French. Jaana? I like it. Jaana is attempting to solve a quadratic equation by completing the square. What number should she add to both sides of the equation in order to complete the square? So remember, when you're trying to complete the square, what you're trying to do is you're trying to make a c value, right? In this case, you have the x squared plus 7x, right? I'm trying to make some c value that when I'm done with it, I can turn it into a perfect square where it's going to be like x plus something squared, okay? So, and this is going to be plus something here squared, right? It's going to be actually half of 7. So anyway, the way that we do that is we take and we're going to take this 7 here. You take your b term and you divide it by 2. I'm just telling you this is what you do. You take your b term and you divide it by 2. If you want to know why you divide it by 2 and things like that, if you really want to know, when we get back to school, I can, you can come see me after school and I'll explain to you why that is. We'll actually work it out together. But basically what you have here is you have 7 divided by 2 is equal to 3.5. All right, so you take that 7, you divide it by 2, you get 3.5. Now this 3.5 here, or you get 7 halves, you could leave it as a fraction, right? That 3.5 here, I have to do a second thing with it. I have to take that 3.5 and I'm going to square it. Now, and that's going to give me another number. Now this 3.5 is a very important number. I'm going to use it to put inside those parentheses. Okay, this is going to become my x plus 3.5, right? Or plus 7 halves, however you want to do it. In fact, I'm going to leave it 7 halves because I like fractions. They make me happy on the inside. So x plus 7 halves squared is equal to, so what's the number that we would add to both sides? I'm going to take that 7 halves. So really it's 7 halves. 3.5 squared is really 7 halves squared, right? Which if you think about it is really 7 halves times 7 halves, right? So since that's the case, basically you end up with what? 49 over 4, right? I'm going to go ahead and do that in my calculator. Or really, I mean, that's the number I'm adding, 49 over 4, right? I could leave it like that in theory, right? But what I'm going to do is I'm going to take my calculator and actually turn that into a decimal. Let's assume it's like a griddable or something like that, right? And you need to come up with a decimal. So when I do 49 divided by 4, I get equal to 12.25. Once again, this is a point. So 12.25. So the number I'm adding to both is 12.25. I have to add that to both sides of the equation, 12.25. Now, the reason I do that, the reason I want to do that is because now, with that 12.25 there, I'm basically saying that this is the same as this. And I can actually show you that that's the case because it's gotten a little bit fun to watch. Look, if we have x plus 7 over 2 squared, right? X plus 7 halves squared. What we're really saying is x plus 7 halves, right? Times x plus 7 halves. I'm going to show you that they're equivalent. I'm going to show you why we can make this jump here, right? X plus 7 halves and x plus 7 halves. I FOIL out. I get x squared, right? Plus 7 halves x, right? Plus 7 halves x, right? Plus 49 over 4. 7 halves times 7 halves is 49 over 4. So this is really x squared plus, it's really 2 7 half x's, right? Which is really just plus 7x, right? Or if you wanted to do it differently, it'd be 14 over 2x, right? Which simplifies to 7x plus 49 over 4, right? And as you can see, this x plus 7 squared was the same exact thing as this up here, which is the 49 over 4. 49 over 4, remember, is 12.25. So as you can see, that's why we can make this jump, because they are equivalent. And once again, the way we got that that equivalency there was we took the 7, we divided it by 2 to get 3.5. That tells us what needs to go in here. That 3.5 or 7 halves is what we finish. It's what it becomes, all right? But once again, to get that C value, we had to take that 3.5 then and square it, or the 7 halves and square it. All right, hopefully that made sense. Let's go ahead and I should do a video on completing the square. I think that would make people happy on the inside. All right, here we go. The arch below has the shape of a parabola that begins at the origin and has a vertex at 3.67 and 13.47. Other than the origin, at which point will the graph this should be intersect, okay? I'm going to go ahead and rewrite that. Intersect the x-axis, okay? So other than the point of origin, which point will the graph intersect the x-axis? So it intersects it here, and right now, you might be panicking. You're probably thinking to yourself, what? They gave me the vertex, right? And they don't really give us a lot of other information, but they want to know basically when will this, if I were to extrapolate this data, basically somewhere around there, right? Where will this touch? And we don't want to guesstimate this. We don't want to kind of try and figure it out without actually like knowing it's correct, right? What you could do, like if it was a nice really thing, what you could do is you could actually print this out and then fold it on itself, right? But you could also remember that the vertex is also known as the line of symmetry, right? So it's also known as the line of symmetry. So because it's the line of symmetry, right? Imagine that this is the line of symmetry here, right? So if this is my line of symmetry right here, I'm saying I can fold it on itself, right? Well, then let's think to ourselves for just a second. If this is my vertex and the vertex point is 3.67, 13.47, what we're saying there, right? What we're saying is that this is the x value and this is my y value of that coordinate, right? Of the vertex, which is right here. So if you remember, when you are plotting a point, you go your x distance is 3.67, and then I'm going to go up my y distance, and my y distance is 13.47. Well, if this distance is 3.67, and remember the vertex is where you'll be able to actually fold the thing onto itself because the axis of symmetry goes through the vertex, right? If that's the case, then my next point must be the same distance in this direction. So it's going to be another 3.67. Does that make sense? And hopefully it does, because basically what you're saying is you can fold this parabola onto itself, that it could be folded that way. In other words, this point here, if I fold it, it should be like wherever that point is over there, right? And then likewise, same thing, this point's going to fold over to make that other point. Make sense? So if this is 3.67 here, then you know this distance here has to be 3.67 as well, right? This distance right here. So 3.67 plus 3.67, I'll just do it right here, 3.67 plus 3.67. Let's do a blast from the past math. Yeah. So we'll do some simple addition, 12, 13, right? So you should have got 7.34, which is answer choice G. The crowd goes wild. That was a horrible crowd goes wild. You get the idea. All right, here we go. Boom, 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 boom. Pardon me. So write an equation of the line. This will be the last problem that we do. So hopefully this has been enough for you to get your good grasp of the material and get your feet under you. Write an equation of the line that's parallel to the line 4x minus 5y is equal to 15 and passes through the point 30, 30. So remember, this is your x1, this is your y1, right? And they want an equation of the line that's parallel. So let's just remember a couple things. If lines are parallel, what we're saying is that they have the same what? They have the same slope, but they must have different y-intercepts, right? Different y-intercepts. But this is the key thing that I'm going to use right now. If it's going to be parallel, it has to have the same slope. So in this case here, I have 4x minus 5y is equal to 15. Unfortunately, as this is called standard form. But standard form, although standard form is useful from time to time, you're probably wondering why, because we never really showed you how it's useful. But it is useful. There are reasons why it kind of gives you the big picture of a line and things like that. But anyway, moving on. The standard form has the same, like I said, we want the same slope as this line here, but I can't figure out the slope from here. So I'm going to take that line, 4x minus, what is that, Mr. Sims? 4x minus 5y is equal to 15, and I need to get it into a format where I can find the slope. Well, if you remember, one of the ways that we can find slope is by getting it into the format y is equal to mx plus b, also known as slope-intercept form. It's called that because you can find the slope and the y-intercept from it. So this is slope-intercept form. If I can get to slope-intercept form, right, then I will no longer be clueless about what that slope is, and I'll be able to make a parallel line with the same slope. So I have 4x minus 5y is equal to 15. I'm going to take that 4x and move it to the other side because I'm trying to get y alone, right? Over here you can see in the form y is alone. So I want to do that. So these cancel out now, and I get negative 5y, be careful with that negative, is equal to negative 4x plus 15. Next step is to divide by negative 5, and divide by negative 5, and divide by negative 5. Everything, basically you're dividing everything by negative 5. So I get y is equal to 4/5 x plus 3. No, haha, I almost made a horrible mistake. Minus 3. Because positive divided by negative is a negative. So I get y is equal to 4/5 x minus 3, right? And that right there is my equation of this line in slope-intercept form. But this is the key ingredient that I need for that line. I need that 4/5 because my new line, right? So this is my old line, right? Right? This is my old line, right? This is my old line in slope intercept form, right? This is my old line in slope intercept form, right? Now I'm going to start making my new line. I'm actually going to change the color for this just so we're not confused. So, Alexa, stop the timer. Right on time. All right, so I'm going to take that slope of 4/5, right? And I'm going to make a line. Now, I have a slope and I have a point that they gave me. So I'm going to use point slope form, which is y minus y1 is equal to m times x minus x1. It's called that, once again, because y minus my y1 is equal to m times x minus my x1. That it's called point slope form because you can find the slope from it and a point, or you need a point in the slope to make the line is another way you can think of it, right? So I have my slope. Remember, it's going to be the same slope if it's going to be a parallel line. So I'm going to take that 4/5, I'm going to plug it in, right? That 4/5 is now plugged in. So right there, that's going to make my line either the exact same line or parallel to it, depending on what my other point is, right? And then I'm going to go x minus my x1, which is 30, and y minus my y1, which is also 30. And that right there is a very valid answer for this problem because all they tell me to do is write an equation of the line that is parallel. And this is an equation of the line. Now, if I wanted to go one step further, and I'm just going to do it because I'm a math teacher and I like math. So if I wanted to go one step further, what I could do is turn this into slope-intercept form. I would do that by multiplying in the 4/5, right, to both of these, distributing it in. And I get 4/5 x, right, minus, 120 divided by 5 is 24, right? Minus 24. I did that right? Yeah, I did. So 4/5 x minus 24 is equal to y minus 30, right? Then I'm going to add 30. That's my last step, 30. So I should get y is equal to 4/5 x plus 6. Haha! And this right here would be my answer. Once again, these both would be valid equations. Whoa, didn't want to do that. Let's try that. Both of these would be valid equations that work. In fact, you'd probably want to stop right here because they don't ask you for it in slope intercept form. But I like slope intercept form. It makes me happy on the inside. So I'd prefer that answer personally speaking. But anyway, like I said, either of these would work. They're both the same exact line. All right, well, let's go ahead and look back at what we've done. We've done some amazing things. We've talked about relationships being causal or and not causal, right? Correlations and things like that. We've talked about how to represent weak or strong correlations, right? Strong positives and so on and so forth, right? We've talked about how to write equations of the line given data and things like that. So we've basically had a fun time here today. I hope you're having a great time with your family. I do hope that you're staying safe. Please make good choices. Obviously, a lot of people out there we're caring about, and we just want to make sure that everyone's safe. So please, although I can't be with you, I wish I could give you guys a fist bump. I do hope that you are, like I said, being wise, and I do hope that you are enjoying this craziness just a little bit. But at the same time, just know that we care about you very much and we want to get back to you guys soon. Once again, I do commend you for doing this. Oh, in the bottom left-hand corner, go ahead and draw what you would love to do as soon as the stay in place order lifts. So when the stay in place order lifts, what would you like to do the most? All right. And then in the upper left hand corner, say say, I can learn math all by myself. And that's so true. You really can. I'm always here to help you, and I'm really glad to help you. But I just want you to know you are a powerful being who has a great mind. Your mind probably, you have no idea how good your mind is because the truth is you probably never pushed it to the level that it can be. So, use this time while you're out there, while you're having to do some independent learning. Use this time to push yourself, see what you're made of. I bet you'd be surprised. Anyway, I wish you the very best. Good luck on your test coming up. As always, you are amazing, and I wish you the best. Take care.
You're not a voice. You're just a ringing in my ear. And if I heard you, which I don't, unspoken for I fear. Everyone I've ever loved is here within these walls. I'm sorry, secret siren, but I'm blocking out your calls. I've had my adventure. I don't need something new. I'm afraid of what I'm risking if I follow you into the unknown. Into the unknown. Into the unknown.